Hello everyone, welcome to my channel GVS Chem. In this module, let us discuss the chemical bonding part 2, that is ionic bond. This module is meant for the students of classes 9 and 10. Please subscribe my channel, like, share and comment on my videos. In the previous module, we discussed about octet configuration. Octet configuration. What is octet configuration? Octet configuration is nothing but having 8 electrons in outermost shell. Having 8 electrons in outer shell. Outer shell is also called as valence shell. Outer shell is also referred as valence shell. Therefore, outer electrons, that is electrons in outer shell, electrons present in outer shell are called valence electrons. Valence electron. Gases or elements with 8 electrons in their valence shell. Elements with 8 electrons in this valence shell are stable. That is, they do not react with others. They do not react with others. So, atoms with 8 electrons do not take part in reactions. Do not take part in reactions, chemical reactions or chemical bonding. Whereas atoms with less than 8 electrons, they are unstable. Unstable means they have high energy. So, in order to decrease their energy, that means the relation here between energy and stability, greater the energy, less is the stability and vice versa. Therefore, they try to decrease their energy, How do they try to decrease their energy? By getting octet configuration. How do they get the octet configuration? That is by losing or gaining outer electrons. So now let us take some examples. Sodium atomic number 11, configuration 1s2, 2s2, 2p6, 3s1. So here 1 electron is there and sodium loses this electron and attains the nearest inert gas configuration. Nearest inert gas configuration. What is the nearest inert gas to sodium? That is neon. Therefore, sodium 11 atomic number electronic configuration can also be written in this manner. Therefore, it loses its 1 electron and becomes Na. So, sodium has 11 electrons, 11 protons. Since it loses 1 electron, it gets a positive charge. Therefore, this is a sodium cation. So, configuration is 2,8. On the other hand, chlorine 17. Electronic configuration 1s2, 2s2, 2p6, 3s2, 3p5. So, its electron picture, in 3s subshell there are 2 electrons and in 3p subshell there are 5 electrons. Right. Therefore, chlorine is deficient of 1 electron to get the octet configuration. So, for chlorine, instead of losing 7 electrons, it is easy to gain 1 electron from outside. Therefore, chlorine takes 1 electron from outside. So when chlorine takes electron plus E minus, then it becomes what happens? Atomic number of chlorine is 17. It has 17 electrons and 17 protons. So when chlorine takes an electron from outside, it gets a negative charge. Therefore, this is a chloride. This is chloride anion. Chloride anion. Now let us discuss about the formation of ionic bond. Formation of ionic bond. Ionic bond means a bond formed by ions is known as a ionic bond. So a bond formed by ions is called ionic bond. Ionic bond. So what are the examples? Examples of ionic bond. Examples: NaCl, KCl, potassium chloride, sodium chloride, potassium chloride, sodium oxide, magnesium chloride, aluminum chloride, magnesium oxide. All these are ionic compounds or ionic substances. So an ionic substance is that in which an ionic bond is present. Ionic bond is also referred as ionic bond. The other name of ionic bond is electrovalent bond. Electrovalent bond. Now let us discuss the formation of ionic bond. So formation of NaCl. So sodium with atomic number 11, it has a 281, one electron is there in a M shell. This is KLM. So electron present in the M shell is lost. So this is Na plus and E minus. See, to remove the electron, certain energy is required. What do you call that energy? The energy required to remove an electron from the outermost orbit of an isolated gaseous neutral atom is known as ionization potential. Ionization potential or ionization energy. Ionization potential or ionization energy. On the other hand, chlorine, it has a 287. It is deficient of 1 electron to get the octet. Therefore, it takes 1 electron from outside. Therefore, this becomes Cl minus. So, when chlorine takes an electron, certain excess amount of energy releases here. So, the energy released when an atom captures an electron is known as electron affinity. So, here the energy released by electron is known as electron affinity. Electron affinity. Therefore, Na plus ions, a large number of Na plus ions and a large number of Cl minus ions, cations and anions, they attract each other to form NaCl. Na plus Cl minus, and of course, we neglect to show this charges while writing this in the paper. So this is the formation of sodium chloride. Now let us see another substance, say potassium chloride. Potassium with atomic number 19, 2881. So potassium loses an electron and becomes potassium K plus ion and E minus. This is electron. So this is a potassium cation. On the other hand, chlorine atomic number 17, 287. It needs 1 electron. Therefore, it takes 1 electron from outside and Cl minus, chloride anion. So sodium, potassium and chlorine, potassium ions and chloride ions, they come closer and form, we get KCl, K plus and Cl minus. This is potassium chloride. It is an ionic substance. Ionic substance. Now let us see magnesium chloride. Magnesium chloride. MgCl2. So here one magnesium ion and 2 chloride ions attract to each other. Therefore, magnesium, what is the atomic number? 282. Since it has 2 electrons in the outermost shell, it loses these 2 electrons. Therefore, it becomes Mg2 plus and 2 electrons. Because it loses 2 electrons, this is referred as dipositive ion. On the other hand, chlorine, atomic number 17, 287, it takes one electron from outside and becomes Cl minus chloride ion. So here the charge is 1, here the charge is 2. Therefore, to neutralize the charge on cation, it needs 2 chloride ions because the charge on chloride ion is only 1. Therefore, magnesium 2 plus Cl minus, so 2 chloride ions, and we get MgCl2. So MgCl2, which is the charge present on each ion, is neutralized by other ion, that is magnesium chloride. Compounds in electron dot picture. So electron dot picture. Electron dot picture is also referred as Lewis structures. Lewis structures, because these structures proposed by Lewis. Sodium with atomic number 11, 281. Therefore, in Lewis structures or electron dot pictures, only outermost electrons are shown. So, one electron here as dots. On the other hand, chlorine 17, 287. Therefore, chlorine, it has 7 electrons in outermost shell. So, 1, 2, 3, 4, 5, 6. So, here Na, this is electron, plus Cl, these are the electrons. So, here this electron transfers from sodium to chlorine. Therefore, we get Na, it has a plus 1 unit of positive charge. Chlorine, it has a 1, 2, 3, 4, 5, 6. Previously, before taking the electron, it has 7 electrons, and after taking the electron, it has 8 electrons. As it has 1 unit of negative charge, we represent in this manner. Therefore, this is the electron dot picture for sodium chloride. Similarly, let us see the electron dot picture for magnesium chloride. Electron dot picture for magnesium chloride. Magnesium, atomic number 12, 282. It has 2 electrons in the outermost shell. Therefore, Mg with 2 electrons. On the other hand, chlorine, it has 17 electrons. Cl, 1, 2, 3, 4, 5, 6, and 7. 7 electrons are there. Now, Mg, this 2 electrons you can show on any side. 2 electrons are here plus Cl, 1, 2, 3, 4, 5, 6, 7 on this side. 1, 2, 3, 4, 5, 6 and 7. Therefore, the transfer of electron takes place in this manner, and of course this electron to this side. Therefore, we get, as electrons are transferred from magnesium gets 2 units of positive charge. And of course here chlorine, 1, 2, 3, 4, 5, 6, 7. And of course I am showing this electron taken by chlorine from outside. I am showing this with a white mark. So how many chloride ions are there? 2 chloride ions. Therefore 2 Cl2. Therefore this is magnesium chloride. Now let us discuss one more substance, sodium oxide. Sodium oxide. So we have already discussed that sodium with atomic number 11, 281. Therefore, it loses 1 electron and becomes Na plus. That means it has 1 unit of positive charge. On the other hand, oxygen, atomic number is 8 and configuration is 2,6. It needs 2 electrons from outside to get the octet configuration. Therefore, oxygen, let us represent this in Lewis structure. 2 electrons here, 2 electrons here, 2 electrons here, 2 electrons. And of course, we can make in this manner. So this is 1 electron and 1 electron. 2 electrons, 2 electrons, 1 electron, 1 electron. Therefore, now, how the electron transfer takes place, let us see. So this is oxygen atom, 2 electrons, 1 here, 1 here. So sodium plus, it has only 1 electron. This electron transfers from sodium to oxygen. On the other hand, other oxygen atom also. This electron transfers from sodium to oxygen here. Therefore, sodium, since it loses one electron, it gets a positive charge. How many sodium ions are there? This is 2 sodium ions. On the other hand, oxygen received 2 electrons from outside. Therefore, the charge present on oxygen is 2 minus. Therefore, this is a sodium oxide. Therefore, finally we get Na plus 2, oxygen 1 here, 2 here, 3 here and 4 here. Therefore, this is the... Now let us try to understand what elements in the periodic table combine to form ionic bond. So, what elements in the periodic table combine to form ionic substances. So, first group element. What are the first group elements? Hydrogen, lithium, sodium, potassium, rubidium and cesium. So here hydrogen is gas, and for all these elements the configuration is 2-1, this is 2-8-1, this is 2-8-8-1. So first group elements, they have only one electron in the outermost shell. So first group elements have one electron in their outer shell. Therefore, they lose their one electron and becomes alkali, and they become unipositive ion. Whereas on the other hand, second group, what are the second group? Beryllium, magnesium, calcium, strontium, barium and radium. So they have 2 electrons in outer shell, So as they lose 2 electrons, they become dipositive ion. Dipositive ions. On the other hand, if you take 13th group elements, boron, aluminium, gallium, indium, thallium. So they have the electron picture here is 2, 3, 2, 8, 3. So they lose 3 electrons. These elements lose 3 electrons and become tripositive ions. And now let us see what type of elements form anions. So anions formed by what are the 18th group elements? 18th group elements are helium, neon, argon, krypton, xenon and radon. So they are inert gases. Inert gases means they do not react with other elements because their octet is completed. On the other hand, halogens, 17th group of elements are called halogens. What are halogens? Fluorine, chlorine, bromine, iodine, astatine. So configuration 2-7, 2-8-7. So they have 7 electrons in the outermost shell. Therefore, they need 1 electron to form octet configuration. Therefore, they form uni anions or negative ions. Uni-negative ions. If you take 16th group elements. What are the 16th group elements? Oxygen, sulfur, selenium, tellurium, polonium. Atomic number of oxygen is 8 to 6. Atomic number of sulfur is 16 to 8, 6. Therefore, they have 6 valence electrons. 6 valence electrons. 6 valence electrons. Since they have 6 valence electrons, they need 2 more electrons. They need 2 more electrons. 2 more electrons. If they take 2 more electrons, that is O plus 2 electrons become, what happens? This becomes O2 minus. Similarly, S2 minus, sulfide ion, oxide ion. Therefore, they are, what do you call? Di-negative ions. Di-negative ions. 16th group elements are referred as chalcogens. 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 Chalcogens means ore formers. They are ore formers. What we discussed till now? First group, group 1, group 2 and 13th group. Groups, they form cations. They form cations. Here, charge is plus 1, plus 2, plus 3. On the other hand, 16th and 17th group of elements form anions. 16th and 17th group of elements form anions. Here, they get charges minus 2 units and here minus 1 units. Therefore, when these elements combine, we get ionic substances. Ionic substances. See, this is the periodic table which we studied already in the previous chapter. This is the first group elements. They are also referred as alkali metals, and these are the second group elements. They are also referred as alkali earth metals. When alkali metals and alkali earth metals lose 1 and 2 electrons respectively, they form positively charged ions. Here, 13th group, that is boron, aluminum, gallium, indium, thallium, etc. When these elements they lose 3 electrons from their outermost shell, therefore they become tripositive ions. On the other hand, this is fluorine, chlorine, bromine. They are halogens. Halogens means salt formers. They gain 1 electron from outside and become uni-negative ions. On the other hand, 16th group elements, that is chalcogens, they gain 2 electrons from outside and become dipositive ions. Therefore, in the periodic table, extreme left elements form cations and extreme right elements form anions. When cations and anions form, we get ionic substances. Keep the point in mind, 18th group elements, they do not react, therefore they are referred as 0 group elements. They are referred as 0 group. The number of electrons lost or gained by an atom, is called electrovalency. So the number of electrons lost or gained by an atom is called electrovalency. So electrovalency of first group is plus 1, second group, this is second group is plus 2, 13th group is plus 3. On the other hand, 17th group is minus 1, 16th group is minus 2. So how do we get the electrovalency? Electrovalency is nothing but a number of group number. Group number means first group 1 plus 1, second group plus 2, third group, 13th group plus 3. On the other hand, 17th group, for getting the 17th group, 18 minus group number. So for elements which are present on the right side of the periodic table, electrovalency or charge to be obtained on the atom is obtained by 18 minus group number. Therefore, 18 minus group number is 17. Therefore, we get 1. Because they get a negative charge, we call it as a minus 1. Now let us discuss the properties of ionic substances. We are showing the formula of ionic substance, that is sodium chloride Na plus Cl minus. Strictly speaking, this indicates that one sodium ion attracts to one chloride ion. But in practice, it is not like that. A large number of sodium ions attract to a large number of chloride ions in this manner. Now let us observe this diagram. This is sodium and this is chloride. So this is chloride here. So chloride, this chloride ion is attracted by 4 sodium ions from 4 sides, and below this plane one more chloride ion, above this plane one more chloride ion. Thus each chloride ion is attracted by 4 sodium ions, 1 2 3 4, and below this plane one more sodium ion, above this plane one more sodium ion. Therefore each chloride ion is attracted by 6 sodium ions. Similarly, each sodium ion is attracted by 6 chloride ions. So, a large number of positively charged ions and negatively charged ions attract each other in the 3 dimensions. So, such a 3-dimensional arrangement of positive and negatively charged ions is referred as a crystal structure or crystal lattice. From the previous slide, we understood that a large number of positively charged ions attract to a large number of negatively charged ions. So, such a 3-dimensional arrangement is referred as a crystal structure. A large number of oppositely charged ions arrange themselves alternately in 3 dimensions, and this arrangement is referred as crystal structure or crystal lattice. Since oppositely charged ions are held very tightly to each other with a force known as electrostatic force, ionic substances are very strong, hard, and rigid. The boiling points and melting points of ionic substances are very high. Why it is so? Because the electrostatic attractions make the ions to held very tightly with each other. Therefore, what is melting? So, melting is nothing but separation of ions. Since ions are to be separated by breaking the strong electrostatic attractions, they need a lot of energy. The energy required to break the attractive forces is nothing but melting point or boiling point. Thus, ionic substances have very high melting and boiling points because of the electrostatic attractions. Ionic substances are soluble in water. Water is a polar solvent. So, ionic substances are soluble in polar solvents like water. This is ionic substance in which oppositely charged ions attract each other and they are arranged alternately. This is water molecule H2O, and in water molecule H2O, oxygen is more electronegative than hydrogen. Therefore, oxygen attracts electron pair towards it. Oxygen attracts electron pair towards it. Due to this, it gets partial positive charge. On the other hand, hydrogen gets partial negative charge. Therefore, poles are formed. Since poles are formed, it is called polar solvent. When ionic substance is kept in water, a new forces develop. This positive ion attract towards the partial negative charge, and this anion attract towards the partial positive charge. Because of this, the ionic substances, that is the electrostatic attractions, become weak. So, electrostatic attractions become weak. Since electrostatic attractions become weak, ions are separated from each other. Ions are separated from each other. Therefore, it is nothing but solubility. So, why ionic substances are soluble in water? When ionic substances are dissolved in water, the strong electrostatic attractions become weaker or electrostatic attractions are broken completely. Therefore, ions are free to move. This is nothing but solubility. Ionic substances in their fused state or their aqueous solutions conduct electricity. Fused state means NaCl solid. When it is heated to high temperature, ions are separated from each other. Ions are separated from each other. As ions are separated from each other under the influence of electricity, these ions move towards opposite cathodes, oppositely charged cathodes. Therefore, passage of electricity is possible. So, ionic substances pass electricity in the form of their ions, or otherwise, if NaCl is dissolved in water, this is water. So, NaCl, we represent this as aqueous. Aqueous means solution. So, that is, they dissociate into ions, Na plus and Cl minus. Since ions are available, so electricity passes through these ionic solutions and electricity passes in the form of charged particles. Ionic substances undergo ionic reactions which are very fast. For example, if you take lead nitrate solution, lead nitrate aqueous plus potassium iodide, this is aqueous. So when these two solutions are mixed with each other, we get lead iodide. This is a solid substance. The insoluble solid substance forms in the reaction is known as precipitate plus KNO3 aqueous. So this is a yellow precipitate. This is yellow precipitate. So let us take lead nitrate solution in a test tube and potassium iodide solution in another test tube separately. Now add potassium iodide solution to lead nitrate or lead nitrate solution to potassium iodide in any way. When you are adding itself, you can find the yellow solid substance in the test tube, that is referred as precipitate. So this is precipitate. Precipitate means insoluble solid substance formed in the reaction is known as precipitate. So thus ionic substances in their solutions undergo reactions very fast, which are referred as ionic reactions. Let us see the conditions. Conditions for formation of ionic substances. Formation of ionic substances or compounds. Number one, size of the atom. Size of the atom. If the size of the atom is greater, cation forms quickly. Similarly, ionization potential. Ionization potential. If ionization potential is least, then electron is lost quickly, therefore cation forms quickly. And the third one is electron affinity. Electron affinity. Electron affinity means the amount of energy released when an atom takes an electron. When an atom captures an electron, that is called electron affinity. If electron affinity is more, ionic substance forms quickly. And the other one is electronegativity. Electronegativity. Electronegativity means it is a tendency of an atom to lose to gain one or more electrons from outside. If the electronegativity is more, the atom is ready to take electron from outside and become negatively charged ions. So under these conditions, here the first two are for cations. The next two are for anions. So if anion and cation form quickly, then ionic substances form quickly. In the next module, let us discuss about covalent bond.